Hi all, and welcome to the chapter 12 video that is all about loops. Loops are really the final tool that we need in our tool belt or tool kit or whatever kind of analogy you want to make some really powerful programs. When we combine, and what we'll do in the later chapters is start combining loops and branching and functions, all of these things that we've been learning up to this point to make some fairly sophisticated programs. And those are really the building blocks that you'll be using throughout your computer science careers to build programs in almost all of the languages that you'll see. So we're going to go over some exercises that talk about while loops and for loops, and then at the very end we'll talk about when you would use a for loop or a while loop and what you'll see or can expect to see in this class. So this very first exercise here, we have a while loop, and it's asking us, what does this actually do? So when you're given questions like this, what this is really saying is, can you trace through this program? And so what we mean by that is go line by line and say, what is the computer going to be doing? What is going to be displayed to the console, or in the case of processing, sometimes even the sketchpad. So when we start off here at line 1, we see we have this variable I that's getting initially assigned a value of 0. Then we have our while condition, where we use that special keyword while, and then we have a relational expression here. And what we're saying is we need to evaluate whether or not this variable I is less than this number 10 that we've specified. Why 10? It's an example. Usually there's going to be some sort of reason behind the condition that you pick here, but in this case it's just for the example. So the very first time we see this condition, I has a value of 0. So the computer is really evaluating, is 0 less than, wow, 10. And remember, when we have a condition, we're going to be evaluating that to either true or false. And in this case, that will evaluate to true because 0 is less than 10. When that condition evaluates to true, we jump into what we would call the body of the while loop, which is all the lines that are indented 1 over, or maybe even more than 1 over, which we'll see in the next chapter, underneath it. If we had code that was at the same level of indentation, so say we had some lines here that were at the exact same level as that while, only the indented lines would be the body of that while loop. So those would be the lines that would get repeated and repeated and repeated. So because this first condition was true, what happens is we jump into this body of this while loop. The computer is going to print the value of I. So down here, I'll pretend this is my console. So it's going to print the value 0 to start off with. Then it's going to update that variable I to be its current value I plus 1. So in this case, the next iteration of I is going to be when I is equal to 1. After those two lines execute, it goes right back up to that condition to check to see, okay, with my new value of I that I have, is I still less than 10? And in this case, I equals 1 because we just updated it. So we're checking to see, is 1 less than 10? And in this case, yes it is, so that will evaluate to true. Because that evaluates to true, we jump back into the body of that loop. We're going to print the value of I, which in this case is 1. And then we're going to update the value of I. So we're going to say, okay, update that value to be the current value of I, which is 1, plus 1 is 2. So our next iteration, I is going to be a value of 2. And now that we have that new value, we pop right back up into that condition. We say, okay, is 2 less than 10? Yes, it is. So that's again true. And we will pop back into the body of this. And so we will print the value of 2, update the value of I, so that it will equal 3. And this is going to continue to happen all the way up until we have, I'm going to just ... there, printed the value 9 to the console. So I'm not going to go through all of those iterations because that's so many iterations. A lot of you watching me write really badly on the screen. But once we have our value of I is equal to 9, we've displayed the value of 9 onto the console. Then we updated it so that I, for our next iteration, is going to equal 10. We pop back up to that condition, and we're saying there, is 10 less than 10? No, it's not. So that's going to evaluate to false. And we don't jump into the body of the loop. We would skip to the next line in the program, but because there is no other lines in the program, this would just stop. So effectively what this loop here in this little program is doing is displaying the values 0 to 9 on the console. We could do this with individual print statements, but if we did that, we would have to write how many? 10 individual print statements. So that's at least 10 lines of code. This compacts it down to 4 lines of code. And say somebody wanted to change this later on and say, oh, we actually, for some reason, need to print this for 50 up to 49, right? 0 to 49. All we would have to do in this program is change that one number. If we only had print statements, we would have to add in so many print statements to get that same functionality. So the while loop is really going to remove a lot of that extra programming that we would have to do that's very repetitive. Hence why it's in a chapter called repetition, and it's doing something over and over and over again. Here's another example of a loop, and this one is in kind of more of a typical format that we've seen with our processing programs. So we have these 2 global variables up here, one that's probably setting our screen size to be 220, and one that's defining some minimum square size, and we're setting that to be 5. We have our setup function here, which would be called first, which is going to set our screen size to be 220 by 220, because we would just take that global variable into these 2 bits here, right? And then in our draw function, what we're doing is we're taking or defining a square size, and then we're using this while loop. And what is this while loop doing? It's saying, okay, given our current square size, if it's greater than or equal to that minimum square size we defined as a global variable, so remember we're getting that from up here, then we're going to do these 2 commands. We're going to draw a rectangle, the size of that current square, and then we're going to update the square size to be half of its current value. So that's what we're doing here. When we're doing loops, lots of the times in textbooks, if I just go back to the first exercise, we'll see examples where it's just adding or maybe subtracting. But really we can do anything to that variable that's in our condition that's changing the value. It could be division, it could be multiplication, it could be subtraction, addition, it could be by 1, or it could be by larger groups than just 1, whatever would make sense to our problem. So what this is actually is going to end up doing, and it might be a little bit hard to just visualize it in your head, is it's going to start by drawing some really large squares. So that one, the first one here, is going to be 200 by 200. So that should be about 20 pixels shorter than the total screen size. The next iteration of this, square size, which I'll just abbreviate SS for the sake of my awful writing on the PowerPoint here. Square size will be 100 because we're updating it to be its current value divided by 2. So that would be 100. So the next time, this condition here, the computer will say, okay, I have this updated value. Is this condition still true? Well, 100 is still greater than 5, so yes it is. So it's going to draw a new square, 100 by 100, and then it's going to update to be 50. And again, check our condition for our while loop, it's still good, and it's going to continue to do that up until it reaches a point where that condition of some number is it greater than or equal to 5 would be false. So eventually square size will become less than 5 as that loop repeats, and then the squares will no longer be drawn, and the program will effectively end because we won't see anything new being added. Since I know it's hard to trust me sometimes, should always be slightly skeptical of your professors. I did write out the code here. We can run it and we can see once it pops up on the sketch here that is what it's doing. So you can see our gray background here, which would be our total size of our canvas. And then we have all of these squares that represent the loop running with new square sizes up into a point where we get just a little bit bigger than 5, and then it doesn't run anymore. Okay? So that's a little bit of a more complicated example. we're going to do this one together where we'll write this interactive program that's going to have a whole bunch of, or a variable called n circles. And what it will do is draw that many circles on our canvas in a diagonal. And when the user hits the plus key, more circles will be drawn. When the user hits the minus key, less circles will be drawn. It starts off with a value of 3, so we're going to get that functionality working first where we can just see those 3 circles to start out with. And then we'll try to add it up. And we're going to add that interactive piece. And we're going to use this hint down here to help us out for the loop. So quite often in computer science, what you'll see is we need to figure out a way to make something general so that we can put it into a loop and that the computer can figure it all out. So figuring out these types of equations to help us out are what's going to be the most tricky. So in this case, we're saying the ith circle, the center would be whatever that number of circle is times 20 plus 10. So if it was the first circle, I would equal 2. So it would be, I would equal 1. Oh my goodness, I need more coffee. So it'd be 1 times 20 plus 10 to get the circle center. If it was the second circle, it'd be 2 times 20 plus 10. So you'd see it get increased a little bit. And no, we didn't just magically look at this problem and know the math here and have all the perfect variables and numbers into this. We would have done some trial and error to figure out, okay, what do we multiply it by? What do we have to add to it to make it just perfect? And we'd probably try to do a little bit of plotting out on a piece of paper to say, okay, if I have this one here and then this one here, and let's build a grid. But it would take some trial and error. And so when you're doing this in your own assignments, don't just feel really frustrated if you don't see what that general pattern is. Try to work through it. Do some trial and error. See what you can get. Come to help hours. We can help you work through those things. You don't have to do it all on your own, but it won't probably just be right in your face and easy to do. All right, so here is my processing screen. We are going to start off here by setting up our background. So our background, we know needs to be black. So let's just make our setup function. And put our background as black. I will add in my draw function just for now. And, I forgot my def keyword. So def draw. And I'll just put a return in. I always like to make sure, even if it seems really simple, like just this, that I actually did what I wanted to do. And there we go. Perfect. That's what I like to see. All right, so the next thing that this asks us is to have a variable n circles. And now we need to figure out if we're putting n circles as a global variable or a local variable. And one hint is that we need to think about what happens in this dynamic part here, this key pressed function. When we're hitting up plus, we're increasing the number of circles. When we're hitting minus, we're decreasing the number of circles. So because of that, we have some pretty good idea that the number of circles is probably going to be the model part of our program and would have to be the global variable because it's what's going to be modified in that key pressed function, and it's what the draw function is going to use to figure out how many circles to draw. So because of that, let's add it in as a global variable. So remember to do that. You just put it at the very top of your program before your setup function, and you say n circles or whatever variable name you're using, and it had an initial value of 3. We don't need it in our setup function, but we are going to need it in our draw function. So we bring that in by using that global keyword and then the variable name. And I can get rid of this return because I'm going to do some stuff here now. So now that we have that, in our draw function, we are going to want to start off figuring out a while loop that we could use in order to draw all of the different circles that are required by us. So if you remember from the textbook, we can use while loops to do something some number of times. And if we're going to do that, typically what we need is something that we would call a variable counter. And that's just a variable that usually is going to start off at 0 and increase every single time. And then we can use it to check our conditions. So in this case, if I was making a variable counter, I'd want it to be the number of circles that I've already drawn. So I'm just going to make a variable called circle count, and I'm going to give it an initial value of 0. Then that's saying I have drawn no circles whatsoever so far. And then we're going to have our while loop, and we're going to say, so while we still have circles to draw, so and the way that we would do that is saying, while our circle count is less than n circles, then we want to draw a circle. I'm just going to add in some single line comments that kind of help us explain what we're doing here. So while we still have circles to draw a circle. And the way we're going to draw that circle is by using that, oops. Oh, come on, computer. Stop trying to be smarter than I want you to be. We're going to use this equation that I have just peeking out the bottom here. So effectively, this is saying I, but I is just our counter. So we can start that off by just using our circle count. You could make this I if you wanted to. I like using a bit of a longer variable name so I remember what I was actually doing. And in this case, we'll have our ellipse command, and we pass in circle count times 20 plus 10, and then the exact same thing, circle count times 20 plus 10. And again, that's just this equation down here, but instead of using the variable I named my variable circle count. And this is going to be slightly off by 1. For me, it feels like second nature already that all of my counting starts at 0. It's kind of a little bit of a meme within the computer science community that we always start counting at 0. If you wanted this to be at 1 instead, you could have it at 1 instead, but you'd have to modify your condition so that it was less than or equals to, because then you would get an off by 1 error in the number of circles that you'd actually see on your screen. Oftentimes when you're working with while loops, if you see something that's just like slightly off, it's like, oh, I have one less circle that I want, or my number is one like addition smaller than it needs to be. Usually it's just the condition needs to be changed ever so slightly. So switched from a less than to a less than equals, or maybe what you're comparing it to needs to be increased slightly. They're really common errors in computer science, and you'll see them come up time and time again as you practice, and just try not to get discouraged by them. Now I can leave it like this, but if I do that, I'm going to have something called an infinite loop. So if I run this right now, it just like crashes on me. It doesn't even draw anything, which I have an idea of why it might not look like it's drawing anything. But it just does not seem to be doing what I want. And it isn't running it. Is it running? No, it's not running anymore. So it's very bizarre. If I put a print statement in here to try to debug, and I like to just put things like little strings to myself, and be like, hey, is it even entering that? Oh, well, I see it's entering it. And then nothing else is really happening. This is still looking just black for some reason. And it stopped running. What is actually happening here is that this is an infinite loop. Because I'm not updating my circle count, it's not running through the loop time and time again. It's just drawing that circle, that ellipse in the exact same spot. I also just want to see if I change my fill color to be white, if I can actually see my circles pop up. I have a feeling I can't because of the background and the fill might be the same. So let's do that. No, it's really just yelling at me and is not happy whatsoever. All right, well, let's try to fix this. So the very first thing I'm going to do to try to fix this is update my circle count. So after I draw one of those, circle count, I'm going to update it by 1. And when we do that, we're just saying take the current value and add 1 to it. I should also double check that I don't have any spelling errors, at least that I have consistent spelling errors with all my variable names, because knowing me, there likely is some issues there. All right, so we have this now. This should be updating every single time. We have our ellipse that's being drawn. And now if we try to run this, we still don't see anything that we want to. Oh, how frustrating. So to fix, let's make sure that we have a nice color. I'm going to make it red just so that I can see that it's working. I'm going to add an ellipse command here just so that I can see that that is working. And this is all part of the process of debugging. So as our programs get more and more complex, you're gonna have to start doing some of this stuff. And why is this still unhappy with me? What am I missing here? You're going to have to start doing things where you're like, okay, let's try this. Can we see this? Is it entering this part of my program? We often use print statements or different things that we can see that are going to show up in the actual screen. I'm going to comment out, just for the sake of argument, this here and see if that solves my problem. So again, lots and lots of trial and error. Aha! So if I don't have that while loop, this seems to be working just fine. So now I can get rid of this little debugging that I have here. I am going to leave that fill, but I'm going to just make sure that it's white, which should be 255 if I remember correctly. I'll leave my circle count, and then I'm just going to have a while circle count is less than n circles. Let's just print out the value of circle count. And so to do that, I'll just add a print statement, circle count, and make sure that this is working properly. And if I hit run, beautiful. Oh, what's happening here? Why is it still running? Oh my goodness. The reason I believe that this is running is because every time you call draw, it will rerun the program, right? And we're not actually calling draw, the computer is. So every second that it's calling it, or every 60 times a second that it's calling it, it's rerunning that while loop for us. So we get lots and lots of print statements happening out here. But we can see that it is correctly doing the 0, 1, and 2. So great, that's fabulous. I can stop this. I don't need to overload my computer when it comes to those circle counts. Now we can try this ellipse again and see if we can get that working. And I seem to have found where my issue is here. I wonder if any of y'all have found it before me. My ellipse call has 2 parameters. I am missing the size parameter, which was supposed to be 20 by 20. Now if I run this, dun dun dun, where is it? There we go. I got my 3 circles showing up on the screen. One of the things is you can see there's a weird little bit of bleeding there. We can get rid of that by effectively calling the background every single time that draw is calling so that it will reset it, and then it looks a lot cleaner. This will also help once we implement that key pressed function so that if we decrease or increase, it effectively resets that canvas every single time. There, all right, well I got my debugging through and I got that working now. I found my error with my parameters that I was missing. Let's just add in our final function that we need, which is key press. So remember the last little piece that it wanted us to do was say that if the user pressed the plus key, the number of circles should increase. If they press the minus key, the number of circles should decrease. So we need to bring in that global variable and circles. And then we need to use some of our if statements. So if key is equal, which remember is how we do equals, to the string plus, then n circles is going to equal the value of n circles currently plus 1. Else if, and remember from last chapter, if we want more than one type of condition chained up together so that if it's one or the other it will look at, or it will only look at the second block if the first one is false. We do another condition here. Key is equal to minus, and I spelled key wrong. This is fabulous. My typing skills, great. Then we do n circles we'll update that value to be the current value of n circles minus 1. Okay, now if we try running this, we got my circles, and if I do plus, I get more circles. If I do minus, I pressed plus a whole bunch of times, so then I get less circles, and you can keep playing around with that. So this works well because we have this generalization here for our x and our y coordinates. And again, we had to find that out through trial and error. You wouldn't probably just be able to pick that out of nowhere. You got to kind of draw it out and figure out, okay, does that make sense? And try it out in programming, and then you'll know for sure that it's what you were looking for. All right, get rid of all these sketch pads. Okay, so the other type of loop we talked about in the textbook was for loops. So for loops are very similar to counting while loops. They kind of go through a sequence of information. So in this case, we have this function called print string, and it's using that for keyword to say for this variable that's inside of some sequence that we're passing in, print whatever's in that variable. And in this case, we're passing in this string CMPT 140. And so it's going to be the value that's associated with S. So effectively, we have for, oh, I really wish I wasn't deciding to write this out right now, but that's okay. CMPT 140. And what this is going to do is go through every character in that string and run through the loop once for each character. And at the end of the loop, it's going to switch to the next one, and the next one, and the next one, and so on and so on. So what will end up happening with this one is CMPT 140 will get displayed to the console just vertically, including a line that's just the space, and you'll see it all the way down. So you can write that out in processing if you'd like to try it and see it for yourself. You could try a different string and see if it gives you the output that you would expect. Oops, sorry. We also talked in the textbook about this function called range. So that range function is often used with for loops to help for counting. So if we know we want to do something 10 times, we'll often make a for loop that will say for I in range 10. And that will execute all of the body of the for loop 10 times. So range is a way that we get a sequence of numbers. You can pass in just a single value, a start and an end, or a start and an end and a step. And your step could be positive or negative. And so what that will do is it will always, if you pass in the single one, it's going to start from 0 and create a sequence that goes from 0 all the way up to 1 before the number you pass in. So in this case, it will be till 9. So you always are going to be off by 1 in the end part. And if you put in a step, that means instead of it going up by 1 each time, it'll go up by that step amount or down by that step amount. So what I want you to do is convince yourself that you know what the answers are to all of these function calls, or what they would produce, as well as how to write the range function calls for these ones here. And then go into processing and just wrap those in a print command. So remember how we can nest our function calls? So you wrap that and see if the output that it gives you is the same as what you thought it would be. And similarly to this, write the range command that would generate that output for you and print it out and make sure that it works properly. Okay? After you've done that, I want you to use or test your knowledge with this question that we have here. So you're going to use a for loop. So remember the syntax for that is that for some variable that you'll define with that in keyword some sequence. And you're going to have a program that's going to display alternating yellow and blue rows. If you'd prefer different colors, I'll allow it for this question. Feel free to make a nicer color combo if you would like. The height of each row is going to be given by the row height, which is this equation that we have here. So we'll take our screen size, which is 200, and divide it by the total number of rows that we would have. The first row is going to be yellow. Again, if you pick a different color, you'll be able to figure that out. And so for every other iteration of your loop, you'll be drawing one color or the other color. So you'll have to figure out a way that you can do that or figure that one out. If you want, there's a couple different ways. So you could draw each of those rectangles individually, or you can pick a rectangle to be a background color and then just draw the other colors in the loop. So kind of going up by 2 every time. So there's a couple different ways you can do it. You can check your answer with the answer that we have in the solutions on the course website. If those don't match and you're like, oh, this doesn't quite make sense, then come and stop by tutorial hours or help hours and we can talk through the solution. So infinite loops, what the heck are those? They are the bane of all programmers' existence, especially junior programmers as we're learning how to code. They are a way that makes your program look like it's working, but in fact, it's just running forever and ever and ever and not getting to the end. And sometimes if you have stuff after a loop, it only looks like half of your program is working, and they can be so frustrating. So typically you won't see an infinite loop when you're working with a for loop because you're going to be going through that sequence and the computer is kind of handling all of that on the back end. But when you're using those while loops that have a counter, so in this case, let's just make a counter called I. Very often we'll use I or N as our counter variable names. Say we had a while loop that says while I is less than 10. Again, beautiful example. Then we're going to print I. And we ran this. We're like, beautiful. This is going to print I from 0 to 10. Why is it just printing 0 forever and ever and ever and ever and never stopping? It's because we didn't update this counter. So what we would need to do is always have that update at the end where we're doing something to it. So we're adding one to it. We're doing something that's going to make this condition eventually be false. Once you fix that and add that counter in and you rerun it, is my computer okay? it's not happy with me. There we go. That I ran an infinite loop, but then you'll see you get the output that you expect. So very often if you have a while loop in your code and something kind of weird is going on, make sure you have that line in your while loop where you're updating one of the variables in your condition, because it might be just that you have an infinite loop. You can also stop by help hours, etc., etc. We can take a look and we'll probably find it relatively quickly if that's the case. I can help you fix it. So while loops versus for loops. We will honestly probably predominantly be using for loops in CMPT 140. So while loops you'll typically only need to use if you want to check for a very specific condition. You can use for loops to do what a counting while loop will do, and it will prevent you from having an infinite loop. So we usually recommend those instead of using a while loop. So the vast majority of the time we're going to be using for loops just because we're going to be stepping through some sequence or doing something some number of times. The few cases where we would be using while loops will probably tell you if it's like an assignment or something like that. And if you'd rather use a while loop than a for loop, you're more than welcome to as well. All right. So loops are very tricky. Give yourself some time to practice with them. Be kind to yourself as you're learning them, and really take time to ensure that you really understand what's going on with them, because they're the foundation of what you're going to need throughout all your computer science courses. And then I will see you in the next chapter.